Hello everyone, my name is Mukul Chandra and I welcome you all to CFD Simplified. In this video, I'll show you how to run OpenFOAM simulation using parallel processing with the help of the DecomposePar command, which will significantly reduce your computation time. Alright, so first let us discuss about what is DecomposePar and why it is being used and what is the application of that. Okay, so DecomposePar is basically an OpenFOAM utility which is being used to divide the whole domain into multiple subdomains. Multiple subdomains for parallel processing. Okay, parallel processing. All right, what does this parallel processing means? It means that to run the simulation simultaneously on multiple cores. Okay, like for example, currently I'm using a laptop. Okay, so it is having its CPU is having only 4 cores. Okay, so if I normally runs it without decompose par, so it only uses the single core. All right, or we can say one core only. But if my domain is large, okay, if domain is large or means it contains millions of nodes, for example millions of nodes, okay, millions of nodes, so in that case we cannot run that simulation on one core. Means it will not be feasible for us if you run that in a single core. First of all, it will mostly it will try to crash. Okay, if millions are there, but I'm just taking an example. Okay, so it will not be feasible to take that much number of of nodes in a single core. All right, so to solve that part, what we do, we just divide that mesh. For example, this is our domain. Okay, and we are having a mesh. All right, let me change the color. And we are having a mesh. Okay, like this type of mesh we are having. All right, so what decompose part does, it just divide the mesh or the domain into number of subdomains, like into number of parts. We can say in the language of OpenFOAM we say it subdomains, but in a normal way we can say that it divides it in parts. Like for example, we can consider this is one part, this is second, third. So what you can do in the processor 0, like for example if you use this decompose par command, and in the decompose par dict, for example, which I will explain later on. There you have mentioned 4 cores. Okay, so what it will do, it will create 4 directories. Name processor 0, second one will be processor 1, third one will be processor 2, fourth one will be processor 3. Okay, so the processor 0, processor 1, processor 2, processor 3. Okay, so what it will do, it will divide this domain or the mesh into 4 parts. Like first part will be like this, second will be like this, third will be like this, and fourth will be like this. Okay, so like it will go into 0 processor, it will go into first, it will go into second, it will go into third. Okay, so like this it will do. And then what it will do, so only the processor, the first core, like it is it is talking about cores. Basically the name is coming to be processor, but it is talking about the core. Okay, so the first core will be solving only this part of the domain, second core will be solving only this part of the domain. Sorry, let me yeah. So the first core will be solving only this part of the domain, second core will be solving only this part of the domain, third core will be solving only this part of the domain, and fourth core will be solving only this part of the domain. So it will, increase the, it will decrease the load, it will decrease the load on the CPU, and it will increase the speed of the simulation. Okay, it will increase the speed of the simulation, because a single core is will not be solving the whole domain. Okay, it is divided. So that is the use of decompose par, and that is the running of the simulation in the multiple cores, that is known as the parallel processing. Okay, so that's why it is very very useful. Right now most of this in the tutorial which you find in the OpenFOAM are basic. You can run those in the single core, but like this tutorial which we are using, that is the wing motion. Okay, okay, let me okay, that is the wing motion. So this wing motion part, this wing motion tutorial, if you want to run it in a single core, it will take time, it will definitely take time. Okay, so it take much time as it will take as compared to it if you try to solve it parallelly. Okay, so that is the thing. Now let me explain you the decompose pardict. Okay, so till here it is same, which is the which function you are going to mention. Like if you are like we have seen in the block mesh, so the name of that file is block mesh dict, means block mesh dictionary. So that you have to mention in object. Here we are talking about decompose par, so we have to mention about decompose par dictionary, and that dimension, the how to mention it, we have to mention it like this, decompose par dict. Okay, now comes the number of subdomains. What does that mean? This means number of cores. Basically, like how many domains you are going to divide, it means that how many cores you are having. So you can always mention it less than or equal to maximum number of cores in a CPU. What does that mean? Okay, like for example, the if I'll take the example of my laptop again, so the maximum number of cores in my laptop is 4. Okay, the maximum number of cores in my laptop is 4. All right, so so in this maximum number of cores in my laptop is 4. So I can mention either here I can mention 1, or I can mention 2, or I can mention 3, or I can mention 4. Okay, if I'll mention 5, if I will mention 5, then it will give me error, because it will check my system compatibility, and while checking it will find that no, this system doesn't have the 5 cores, it is having maximum number of cores 4. So it will give me error that no, you are mentioning it wrong. Okay, so if you are try to run like you are having a very good workstation, and it has 16 cores, 16 cores. Okay, so if it has 16 cores, then you can mention here in the number of subdomains as less than or equal to 16. Okay, either you mention up to 16, or you can mention less than that. Okay, not more than that. So that this is the meaning of this. Okay, yeah. Next is method. Which method you wanted to use? Okay, so there are two methods of decompose par. First one is simple, second is scotch. Okay, I will tell happen in that part is like, yeah. So I will explain you about that thing. No worries about that. But here it is in this example, it is only using simple. Okay, here in this example it is only using simple. So here you can see that it is next one is the coefficients. Okay, next one is the coefficient. So here you can see that it is written 2, 2 and 1. Okay, so that 2, 2 and 1 means that the number of subdomains in x direction, the first one means number of subdomains in x directions is 2, number of subdomains in y direction is 2, and number of subdomains in z direction is 1. Okay, so that is the meaning of this coefficients. Okay, this is the meaning of the coefficients basically. All right, so yeah, this is the decompose par dict, a very simple one. This is scotch which I have mentioned here is a complex one, not a word much complex, but yeah, it is a complex one. All right, so what we can do is like we can we'll explain. I'll explain about that. No worries about that. Okay, I will make a separate video on that, that what are the different methods of simple of the decompose par, and there I will explain about scotch. Okay, I think third one is also there. I don't remember about that. I think 3 or 4 are there, but these two I know because the scotch I have used, so that's why. Okay, so I'll explain about that. Okay, so now let's move on of the to the application of this decompose pardict in the Linux terminal and try to run the simulation. Okay, all right. So now we know what is decompose par, why it is being used, and what is the application of decomposePar, and we know about how to set up the decomposeParDict. Okay, like I've explained you for this specific case. I've explained you how they have made the decomposeParDict. Okay, all right. So now let us apply this decomposePar in the live simulation. All right. So this is one of the case. I am just doing the tutorial using the tutorial of wing motion, which is available in the OpenFOAM tutorials. You can open it by typing cd foam tutorials, and then you will be able to find this wing motion inside incompressible pimple foam. Okay, and after that also you have to after copying that wing motion tutorial, you have to make some settings to reach the step till to run decomposePar. Okay, so I'm not going into that. I will make one full wing motion tutorial in which we will set up from the starting, and then we will run the whole simulation. Okay, so I'm not going into that. I'm just skipping that part. I've set up all the things beforehand only, and I am just running the decomposePar command. Okay, that is the thing. But before that, some commands have to be set up in front of you also, so that's why I'll be setting that up. Okay, so I'll open wing motion to the pimple foam, and I will just copy this 0.org to 0. Yeah, so one tip for you all, like in between the videos I am giving some tips also. So yeah, OpenFOAM will not read 0.org. You have to copy in this 0.org to a 0 directory. Okay, the files of 0.org to 0 directory. All right. In some cases, whether in the OpenFOAM tutorial or in the internet, you will find that 0 is represented by 0.org. If you run with this 0.org, OpenFOAM will not run your solver. The solver will not run. Solver will read the boundary condition directory as 0. So keep that keep that in mind, that your boundary conditions name directory name is 0. All right, that is the thing. So yeah, so it has been copied. Now one command have to be run. So let me run that home, my name, and then okay, then I will run. Okay, don't worry about this command. I will tell you about this when I will be making the full tutorial video of this specifically this wing motion. Okay, don't worry about this, just skip this one and the next one which I'll be going to run. Okay, now this one. Okay, now we have to run DecomposePar, and how you can run it? By typing this command DecomposePar. Okay, so now what this DecomposePar has done, it has divided my domain into 4 different cores. Okay, so yeah, you can see that 0 and when the numbering of the core will always start from 0, it will not start from 1, like it will start from 0 to 0, 1, 2 and 3. All right, okay, so now it has divided, everything has been set up. Now only we have to do is like uh, type the name of the solver and press enter. Okay, so the solver which we are using to solve the transient case is the PimpleFOAM. So I have typed the name and then I'll press enter. Okay, so it will be running. Okay, I forgot to change something. I think that I must have done beforehand, so let me do it. Okay, I will remove these directories first. Just a minute. So yeah, so because in the control dict file, if you will go, you will find that the simulation will run end at 5 and the delta t is 1 into 10 to the power of minus 5, means 0.000001. Okay, so that will take much time. Okay, and I don't want to take that, so I will change delta t. I will make the end time to 10. Okay, and I will make delta t 1, and it is asking for the right interval. I will change it to 1. Okay, and everything I will keep it as like this. Let's see if it will run or not, because if this maximum cool, it will not match the maximum coolant number, our simulation can blast off also. Okay, so let's see if it is running or not. Okay, I think it will run. Okay, so yeah, I will again type PimpleFOAM, press enter. Yeah, so all these simulations are now running in our parallel course. Okay, it is using my full course. Okay, if I'll open my task manager, yeah, you can see that where it is, yeah, terminal. Okay, yes, it is not showing. I think it must have ended or what. It is a very light simulation. Okay, that's fine, because in my case, what which I've shown you in the video of snappy hex mesh. Okay, like the which I've done during my masters. Okay, there this my laptop was not able to handle that. Okay, because that one was the complex one, and if I try to run that with the 4 cores, it will only be right if it will, run. For example, if I'll run this on my on that simulation on my laptop for example 8 hours, it will only be able to write up to 1 second or 2 seconds, and I have to write that simulations, the time step directory which I want with the results is like up to 100 seconds, 80 seconds to 100 seconds. So I cannot run that. Okay, this I can run, but that case I cannot run. Okay, so yeah, it is running, and where it has reached, up to 0.0. Yeah, so what I was telling you, that has happened, I think. Let us check inside wing motion how much it was able to write. Yep, it is not able to write the things. Okay, yes, it is showing some errors, so I think we need to change our this control dict to the default one. I've told you that if you what I'm doing, yeah. So you have to set in the case of the transient one, you have to set this delta t according to the maximum current number. Okay, so yeah, it is giving you the error. Okay, and the end time was 5 seconds and the right interval was, yep, it was there. Okay, so we will do it in that way. Okay, no worries. With this exercise I want to show you that how this delta in the transient case, how this or unsteady, how the simulation depends on choosing the correct delta t and maximum current number, because for this simulation this delta t and this maximum current number works. For others may or may not work. Okay, so yeah, I don't want to waste the time on which is working on which is not working. We will do one case of that also, no worries about that. Okay, all right. So but my problem is why it is not showing decompose par directories. Yep, it is, they are here. Now we will run SimpleFOAM. Okay, and now it will take some time. Okay, so yep, it is there, it is there. Let us check 0.018 and 0.19. Okay, it is running quite good. We will, okay, let me pause it, and because it will take time to complete up to zero point 0.5 seconds also. So let me skip that part, and when 0.5 seconds will be written, I will continue the video from there. Okay, okay, so let's stop and check how much it has written. Okay, it has written up to 0.4. Okay, right. So yeah, let me tell you one more command. If you wanted to stop your running simulation in between, if you're running it on your computer, okay, so you only have to press Control and C to, Control C means cancel. Okay, we are canceling the simulation right now, so it will cancel there on. Okay, if you wanted to if you're running it on the high power computing system, then there is some other command I will tell you if I'll got some access of high power computing systems. Okay, then I will tell you there. Okay, but right now if you want to run it, if you want to cancel it on your computer, if you are using that, so then you have to press Control C and it will stop it at that time only. Okay, so yeah, was one of the commands which I want to tell you. All right, so let's make the foam file. So I will give the name to it to foam and type its extension .foam. It has been created. Now I will type paraview.exe foam.foam. Press enter. uh, yep, apply. Yes, and here we are having the result. If I'll run it, so it will run up to 0.3, 0.4. Yeah, you cannot see much difference. You can see that it is moving upwards. Okay, it is moving upwards. Yeah, you can see that. Yeah, so I have came it to end. I bring it to the start, so at 0.01. If I'll bring it to end, you can see that the wing has moved upwards. Okay, wow. If the animation video of this is going to be made, then it will be like, wow, I'll make it and I'll post it on my LinkedIn also. It will be a very good simulation, and I will make a full tutorial video for you guys. and then from there we will make one animation video also, and there I will also tell you how to make the animated video from the paraview. Okay, how you can generate it. So yeah, it is, the simulation is really good. Okay, yeah. So yeah, so like this you can use DecomposePar to run your simulation parallelly. Parallelly simulation running means by running your simulations in the different cores of the CPU of your computer which you are using. So that's how you can speed up your OpenFOAM simulation using DecomposePar. If you found this helpful, don't forget to like, share and subscribe to CFD Simplified. Also, let me know in the comments if you have any questions or if you would like to cover more advanced parallel processing techniques. See you in the next video.